Today's notes are on 5.9, trial and error by grouping. There's a coefficient on the quadratic term, and I highly recommend using pencil for this, as the trial and error can get pretty extensive. Alright, so normally for the warm-ups I would ask you to pause the video and try them yourself, but I'm going to take you through this one. I want you to notice that there are groups of the same factor. So it's like having a common factor. And just like GCF, you would take out right away if you can. That's what we're going to do. We're going to take out that common factor of x minus y from each term. So we would have that factor of x minus y times what's left in each term, which is x minus y plus x. And those are your factors, but of course we can simplify our like terms. So you have x minus y times 2x minus y. And then that is factored. So a little different than we've seen before, but it's like taking out that greatest common factor. And that's kind of what we're moving towards today. At first glance, this second warm-up would look maybe non-factorable, but you can group them in pairs and pull out common factors. So if we look at the first two terms, we can pull out a common factor of p squared. And then if we look at the second two terms, we can pull out a common factor of of 2. And when we group and pull out those common factors, you can see then we have another common factor we can pull out across those terms. And so if we pull out that common factor of p minus 3, and that would be multiplied by the two terms left. So a little bit different, that grouping and pulling out a common factor, and that does take some trial and error before you might find that you have those common pieces. So in example 1, I want to clarify some vocabulary for you. So that 14x squared, that is the quadratic term. And that 17x is the linear term. And as you know already, the plane 5, that is what we refer to as the constant term. So when we're factoring this and we have a coefficient with that quadratic term, we want to look at factors of 14 and 5, so the quadratic and constant term, factors of 14 and 5 that add, and that's because of that sign there, up to 17, and that's because of that middle term. So I want to think through my factors of 14 and my factors of 5, so I would recommend you pause the video and just make a list of those. Alright, so I've made a list of the factors of 14, you can see that here, and the factors of 5. And then what you'll see over here is that list in combinations, and this should make evident why the trial and error process can be a little more difficult. You do have to try some things out sometimes. So these are all the combinations, and then you're looking at trying to put those together into, their multiples, adding up to 17. Now I can see that 14 times 5 would just be too high. That's not going to give me 17. And here those would be too high as well in the next set. But it's this here, 2 times 5 being 10, and 7 times 1 being 7. It's those two pairs that will work. So that's what we're going to go with. So looking at that, then we want, a 2 in the first piece and a 7 in the other term. And then we want the 2 and the 5 to be paired up, to be multiplied together. So I'm going to put that 5 in the other factor and a 1. Now we'll look at signs in a minute. Let's get rid of this just to get us out of the way here. And the constant term in the expression is that plus 5. That's positive. So that tells us that the signs in the two factors are the same, and the linear term is negative, so both signs are negative. And so we would put our x in, and both signs being negative. All right, so a lot of little pieces there. You might have to try some things out. Remember, you can always FOIL to check. All right. Now another way we can accomplish the same thing is to factor by grouping, and it's kind of like undoing that middle term. But to do that, we look at the quadratic and constant together, and so we will multiply the 14 by 5, and that gives us 70. And so we want to think about the factors of 70. And so in this case, I want factors of 70 that will add up to 17, or negative 17. And we replace those into the linear term. So I'm going to look at my factors of 70. I want you to pause and do that as well. Okay, you can see I started to make a list of the factors of 70, and then when I get to a pair that add up to the correct sum, which in this case is negative 17, then that's my target pair right there. So from there, I'm going to rewrite the polynomial. So I've rewritten that there, and you can see that I've changed the subtraction to adding the opposite. Sometimes, just in this case, that's going to be an easier way to handle things, so we suggest you do that. And it is that negative 17x that we are going to break up into this pair. So we will rewrite and say, okay, 14x squared, and that will be the same as plus negative 7x plus 10x. So you can see I'm splitting the negative 17 into those two pieces, plus 5. Now, it's a good idea to take a look here at the order that you put things in. And this is where that trial and error process can take place. I'm putting the negative 7x first because these two have a common factor. 14x and 7x will have a common factor, and negative 10 and 5 will have a common factor. Now you might initially write those in a different order, and then you say, okay, well, 7 and 5 don't have a common factor, and so you have to erase and rewrite. You do want to put them beside the factors, the other terms that will have a common factor, because then we can factor by grouping. So I can pull out a common factor of 7x from these first two and say, okay, that is the same thing then as 7x times 2x plus -1 or -1. And then plus, and then I'm grouping these two, and I can pull out a common factor of 5 times 2x minus 1. I think I missed a negative in there somewhere. Yes, I did. That's that trial and error process. So I pull out a -5, and then that's going to give me that 2x and change that plus to minus to match the other term, or plus negative to match the other term. Then you can see we have the same factor here. So I end up with 7x plus -5 or -5 times that 2x plus -1. Again, check with FOIL. It's that trial and error process. You might not always end up with the right thing right away. So we're going to try another one with the grouping method. Remember, we're multiplying our quadratic term and our constant term. So I'm multiplying 2 times 9, and that gives me 18. So I want factors of 18 that subtract, and that decision is coming from that sign right there, subtract to 7 for that middle term. And so I'm thinking through my factors of 18. I've got 1 and 18, and that won't do it. It's pretty bad, 18 there. And 2 and 9, and those have a difference of 7, so that's going to be my choice. So I want to break up that 7 into the factors of 2 and 9. So I'm going to rewrite my polynomial. And then I want to break that middle term up. So I've got 2x squared. And I want to say, okay, I can break that into a -2x and a positive 9x minus 9. Now I've made a couple decisions there I want to point out. I put the 2 first so it would match the 2 there, again looking for that common factor piece. 9 here to match with the 9 there, common factor piece. I also know that my middle term, I needed to end up with a positive 7, so I needed the higher factor to be that positive factor. So there's a lot of things we're thinking about at the same time here. Then I'm going to group the first 2 terms and the last 2 terms and pull out a common factor. So I'm going to pull out a common factor of 2x here, and that leaves me with x minus 1 plus, and here I'm going to pull out a common factor of 9, and again that leaves me with that x minus 1, and that's what we're looking for, is to have that common piece that we can pull out across the terms. So x minus 1 times 2x plus 9. Again, check with FOIL. All right, in this next one, you're given a hint that you have a GCF. Now, of course, we always handle GCF first. So before we fill out the I want factors of blank, that blank, we are going to pull out that common factor. So here we have a common factor of 3. And that's going to leave us with 5x to the 4th plus x squared minus 6. And then that 3 is just going to kind of come along for the ride, and we're going to do what we've been doing with the polynomial inside the parentheses. So we want factors of, and here's where we're looking again at the quadratic term and the constant term. We want factors of 30 that subtract, and there's that piece, to 1, and that's from that middle term. So thinking through your factors of 30, hopefully arriving at the thought of 5 and 6. 5 and 6. So we're going to break that middle term up into factors of, into addends of 5 and 6. So we have the 3, kind of, again, along for the ride for the whole piece. So we're going to put that in big brackets there. And rewriting, so we've got 5x to the 4th. Now here we want to break up these pieces of 5 and 6, and you've got to think through, okay, we want our middle term to be positive, so I want the higher of the two factors to be positive, so that one's going to be the 6, and the 5 is going to be the minus term. But I also want to place those 5 and 6 correctly, so I want to place them where it's possible they're going to have a common factor with the term next to it. So the minus 5 is going to go right next to the 5 there, and then don't forget that this one isn't a term of x squared, so it's a little different. And then we have plus 6x squared and minus the 6. So again, a lot of little pieces there. We want to place those common pieces together, and we want to make sure that the sign of the higher factor will match that sign of the middle term. Then we can continue to kind of group and ungroup the way that we've been. So we bring down the 3. We want to group these two terms and pull out the common factor of 5x squared, leaving us with x squared minus 1. And then from the next two terms, we're going to pull out a common factor of 6. And again, that leaves us with x squared minus 1. And that's the key. We're looking for that common piece, because that common piece we can pull out across the other terms. So we end up with 3 times 5x squared plus 6 times that x squared minus 1. Now maybe you pull out that x squared minus 1 first. Doesn't matter what order they're in as long as all 3 are being multiplied together. And again, don't forget to check with FOIL. For this next one, you see that we're not in descending order, and you see that hint of how can I rearrange this. So I do want you to rearrange it into descending order. You want to make sure, of course, that you bring along the sign of the terms correctly. So that would be a negative 6x squared, because in the original that's being subtracted. And then plus 11x plus 10. But we don't like when that first term is negative. And so this is where we kind of do that op sum in reverse. So we're going to pull out a common factor of negative 1. And that's just going to change the sign of everything. And so that first term then becomes positive like we like, but then the next term would be negative, and the constant term would also be a minus term or a negative term. Then we can go through and think about, okay, I want factors of what? We want factors of 60. That subtract because of that minus in the constant term. And we want them to subtract 2, what that middle term is, which is 11. So you're going to think about your factors of 60 that would subtract to 11. So listing out some factors of 60 there, you want to look at those. Which pair will give you a difference of 11? Well, that is the 4 and 15, so that's what we're going to use. So our negative 1 just comes along for the ride. And again, we want to break that 11x up. So we're going to rewrite this middle polynomial here. So we've got 6x squared, and we've got that minus 10. So one of them is going to be positive, and one is going to be negative. So you have to think about that. And we also need to kind of look at how we're going to group. These factors are a little bit different, so we might have to try some things out. We need our difference to be a negative. We need our middle term to be a negative, so the higher one is going to be the negative term, and the lower one will be the positive. So we might rewrite this and say, okay, plus 4x minus 15x minus 10. All right, and now again, when you have that minus there, that can get a little awkward, so it's a little easier, I think, if you write it like this when we're going to regroup, okay, as plus negative. So my negative one would come along for the ride, and then I'm going to try and pull out a common factor here, and the common factor in there would be a 2x, and that would give me 3x plus 2, and then I would move on to the next piece, and I'm looking at a common factor between here, and that would give me a negative 5, and then that would give me a 3x plus 2. And of course, that's all one big thing times the negative 1, and you can see I have now a common factor in there. And so I get negative 1, and I can pull out my factor of 3x plus 2 times 2x plus negative 5. Now I'm just going to flip to a blank board here just to continue to show you some differences there. You may have grouped them a little differently. If you had the negative 1 and then you have your 6x squared, and we had put the minus 15x first, again, just with, some trial and error, and then your plus 4x second. I just want to show you what happens there, because so these terms, same idea, but these terms are in a different order. Well then, okay, so we factor, and we've got our negative 1. And from those first two terms, we're pulling out a different common factor. Now we're pulling out a common factor of 3x, and you get 2x minus 5. And from the second two terms, we're pulling out a common factor of 2, and you get 2x minus 5. And from there, okay, negative 1, and then you've got the common factor of 2x minus 5 times 3x plus 2. And so you can see you end up with the same three factors, just in a little bit different order, and that's okay. For example 3, you want to think through, okay, you want factors of 110 that will subtract because of that minus in front of the constant, and they should subtract to 1 AB, and we want the higher term to be negative because we have that minus in front. So just kind of rewriting our polynomial. And thinking through the factors of 110 that would have a difference of 1. And that would give me 11 and 10. Now again, we've got that minus in the last term, so we do want the signs to be different. And because the middle term is a minus, we want the higher term to be minus and the lower term to be the plus term. And we're going to break that middle minus AB term up. Back to red here. So we've got 5a squared, and then we're going to say, okay, let's say I say minus 11ab plus 10ab minus 22b squared. And then I'm going to think through like pulling out a common factor. And when I look at the first two terms, my only common factor is the A. Is the A. So I'm going to look at that. So I'm going to pull out a common factor of A, and I've got 5A minus 11B plus, and then I'm looking at these two terms, and it looks like I have a common factor of 2B, and that would give me a factor in here of 5A minus 11B. And again, that's good. That's what we're looking for, is trying to find that common piece so we can pull that out across. And so we have that 5A minus 11B times the quantity of A plus 2B. And you can always FOIL to check. So at this point, we've looked at several patterns, and we just want to remind you of those. Remember that the first thing we did is find GCFs, and you always want to take out GCFs first. All right, and then the next pattern we looked at was the difference of squares. Remember, that's the twin binomials with opposite signs. And that is only for when you're subtracting two perfect squares. And then we looked at perfect square trinomials. And bad handwriting here. And remember, that is where you're looking at that first term to, just have a coefficient of 1, and you want to check out the sign of that last term in the center. And now we have this trial and error by grouping. So lots of combinations to try. Definitely working in pencil, and bring your questions to class.